Christian. Nice to have you back with us again. Who else is here? And Benedict. So nice, Bartley. Welcome back. Kwandisa. That sounds like a new name. If you are new, Kwandisa, welcome. Michaela. Chad, you back with us, Chad? Cool. This is lovely. And Jaden and Swelihle and Timothy. Cool beans. It's really nice to have it. And Jaden. I don't know if I said Jaden. Jamie Hendrickser, welcome to you. I don't think I've seen your name before. I see Pear, nice to have you with us. Okay, so this is a sort of last push before your exams. Normally what we want to sort of try and do in these Q&A sessions was for you to send me questions, things that you've come across that you weren't able to do. And when I had a look at my email this afternoon, I hadn't received anything. So what I did is I just made sure that I had prepared something myself. And I mean, this is something that in all the time that I've been teaching matrics. How do we send you questions again? Via email. So if you've got something that you want to send, Christian, you're welcome to. Here's my email address. I'll pop it in the chat again. It's lee@watobe.com. Okay, very simple. All right, so for our Q&A session on Thursday, if there are questions that you've come across that you've seen that you don't know how to do, then please email me, okay? And then I can bring that up. So I don't know what the rest of you feel. I don't know how you feel about this today, but I know that the boys that I teach, they often struggle with sigma notation. And that's not something that I think I've really spoken to you guys about a lot. So that's why I thought that today we could talk about sigma notation. How do you feel? Are you happy to do that, or is there something else you would prefer? Hi, Hamid. Nice to have you back with us again. You happy with sigma notation? Yes, sigma. Okay. All right. So okay, cool. Now, listen, if there's stuff that I'm telling you, we certainly can, Christian. If you can send me, you have one particular question to ask. Brilliant, Hamid. Okay, so if you can email it to me, then we can go ahead and we can do that. All right. But if you can send them to me before the time, it's even better, because then I can cut them out and I can put them into a presentation for you. Okay, but no problem at all. Okay, this has got to serve you guys. All right. Now, I don't know how rusty you are. Okay, lee@watobe.com. Okay, Hamid, so just send that to me. All right. Sigma notation is another way of writing the sum of something. No problem, Hamid. Okay, so this weird looking E-shaped thing, I can't even draw it properly. That is your sigma sign. Okay, and all it means is it means add or sum. So in other words, we are now adding things together. So if we've got a sequence, a pattern. So let's say we've got a pattern that goes 1, 3, 5, 7. That's called a sequence or a pattern. But if we've got something that goes 1 plus 3 plus 5 plus 7, then this is called a series. Okay, because we are adding the terms together. Okay, so a series, we can write it with sigma notation, or we can write it using just our normal rule. It means exactly the same thing. Okay, so if we have a look at the way in which sigma notation is set out, let's just go through what it means, right? What you will find is that on top of the E symbol, there will be a number. Okay, at the bottom, there will also be a number. And then to the right, there will be a rule. Okay, now the rule will either be arithmetic, or the rule will be geometric or exponential. Okay, so those are the only two types of series that we look at. Okay, so either we're going to do a geometric series or we're going to do a arithmetic series. All right, the number at the bottom, what does the number at the bottom mean? It is the first value that has to be substituted into the general term. The number at the top is the last value that's going to be substituted into the general term. Now, by general term, they mean this rule in brackets next to the sigma notation. There's the general term. So the first number to be subbed in is 1. The last number to be subbed in is 7. And that's how they generate the terms of the series. Okay, so can you see 1 goes in? 5 times 1 minus 3, that's where the 2 comes from. Plus 2 goes in. 5 times 2 is 10 minus 3 is 7. That's where that comes from. 5 times 3 is 15. Minus 3 is 12. And they continue to sub in. So this is what they get from subbing in 1, 2, 3, 4, 5, 6, 7. That is a series. Right, so this symbol over here is what tells us that we need to add all these terms together and get to that answer. Okay, so now it's really, really important that you understand the way in which it is structured and what it means. All right, so in other words, the number at the bottom is the first number you sub in, the number at the top is the last number that you sub in, and the rule that you are subbing into is in brackets next to the sigma notation. Okay, so the first thing that you do when they give you sigma notation is you start by subbing in. Okay, you have to generate at least 3 terms in the series because you want to be able to see what the first term is. And then you want the second and the third term so that you can either work out the difference, the common difference, if it's an arithmetic series, or you want to be able to work out the common ratio if it is a geometric series. Is that making sense to everybody? Are we happy with this? Thanks, Chad. Yes. Okay, so thanks, Selena. All right, so when we see the sigma symbol, it means that if it is a arithmetic pattern, all right, so that's exactly what it's basically telling us to do, right? If it is a geometric pattern, then it's telling us to use this formula over here. Okay, so if you have a look at this rule here and that one there, what are the big differences? Okay, so you see that there's an R, fair enough. But can you see, guys, the biggest difference between what we've been given here, the one at the top, okay, so in other words, this whole thing here, compared to this one over here, is the rule. This rule over here is an arithmetic rule. This rule over here is geometric. Okay, that's what's super important. Okay, so if you have to look and see if a rule has got an exponent in it, then it means that it's going to be a geometric series, which means you have to use this formula over here. If you've got a rule like this, where you have got a variable multiplied by another number and then something else that's been added and subtracted in a linear form or an arithmetic form, then it means that you've got to use this formula over here. All right, so that is the biggest difference between these two, is being able to look at it and being able to assess straight away, am I dealing with a geometric series or am I dealing with an arithmetic one? Okay, once you have established that from the rule, okay, then you'll know what to do. So in the case of an arithmetic series, we are going to calculate A and D, the difference. And we do this by substituting. Okay, so how do we do this? By substituting. Just as I had shown you in the beginning. Okay, so the number that you have at the bottom is the first number you sub in. The number at the top is the last number that you sub in, all right? So by creating the first three terms in the pattern, you will be able to establish A. Remember, term 1 is A. Term 2 is going to be A plus 1 difference. And if you get term 3, then you will have A plus 2 differences. All right, so you will be able to work out what A and D are. You've got A, you've got D. You're almost ready to work out what SN is going to be. We're going to talk about how we're going to work out what N is now. Same thing over here, all right? If you have now established that your pattern is geometric, again, in order to calculate a geometric sum, you need A, which is term 1. So term 1 is also A, but term 2 is AR. Okay, term 3 is AR squared. Okay, term 4, AR to the power of 3. Okay, so that's why we have to sub in so that we can establish what A is, what AR is, what AR squared is, and that will give us A and R in the case of a geometric pattern. Now, very important, when we are working with sigma notation, how do we work out how many terms there are in the pattern? How do we work out N? Because if we want to calculate, I mean, there's 4 variables here, right? So if I want to calculate, let's just get rid of this. If I want to calculate Sn, okay, which is on the left-hand side of the equation, I need N and A and D. If I want to calculate Sn for a geometric pattern, I need A and R and N. So we've spoken about how we would get A and D from substituting, how we would get A and R from substituting, but how do we get N from sigma notation? Anybody know? That's why I've got it over here. How do we calculate N?
Top number minus bottom number plus 1.
There we go, a C pair. Okay, perfect. Okay, so it's the number at the top minus the number at the bottom plus 1. And this works irrespective of whether your pattern or your series, should I say, is arithmetic or geometric. Okay, so the number at the top minus the number at the bottom plus 1. So now let's go back here and have a look. Okay, so this pattern here, the very first one that we looked at, okay, I want to work out the number of terms in this pattern. How am I going to do that? Number at the top, 7. There we go, number at the top, 7, minus the number at the bottom, plus 1. So in this case, there were 7 terms. And look, you can count them. Term 1, term 2. Ugh, my stupid pen. Stop it. Sorry, guys. So irritating when it does that. Okay, so we were counting the terms. Term 1, term 2, term 3, term 4, term 5, term 6, term 7. Okay, so term 1, 2, 3, 4, 5, 6, 7 terms in the pattern. Okay, if we had a look at this one over here, the first number we are subbing in is 0. The last number that we are subbing in is 7. So now if we want to work out the number of terms in this particular pattern, it would be 7 minus 0 plus 1. So there would be 8 terms in this pattern. Okay. Is everybody all right? I know that I've sort of really rushed through this. Okay. Right, so let's get into some questions then. Cool beans. Thank you. Thanks, guys. Okay, but don't be afraid to stop me if there's something that I've said that doesn't make sense or if there's something else that you want to know. Okay, so now, what can they make us do? All right, well, they could give you something like this, or they could give you something like this, or they could give you a sort of slightly more difficult question like that one over there. We'll have a look at all three of these. All right, so a simple question like this first one. All right, they want you to calculate. So they're asking you to calculate the sum, okay, of a series 7 minus 2m, where m equals 2 is the first number you're going to sub in, and 100 will be the last number that you sub in, okay? Now, imagine how long it would take us to sit here and sub in 2, and then 3, and then 4, and then 5, and then 6. It would take forever. That's why we've got to use the rules. Okay, so what sort of pattern do you see in the brackets? Is it geometric or is it arithmetic?
It's arithmetic, ma'am.
It's arithmetic, absolutely. So if it is an arithmetic pattern, then it means we've got to use this rule over here. That's the right rule for the job. Okay, so calculating SN, calculating sigma notation, what are the three things we need? A, N, and D. Okay, so someone tell me, how are we going to work out what N is? How many terms are there in this particular pattern? Okay. Number at the top, yes, number at the top, minus number at the bottom, plus 1. Good, there are 99 terms. Okay, so essentially good, Nicole. All right, so we are calculating the sum to 99 essentially. All right, so we've got N. Now we need A and we need D. We can only get A and D by substituting. So the first number that we need to substitute in is 2. All right, so now let's go ahead and go and substitute 2 in. So 7 minus 2 times 2 plus 7 minus 2 times 3 plus 7 minus 2 times 4. And on we would go until we eventually subbed in 100. So the first term in our series is 3. The second term in our series is 1. And the next term in our series is 7 minus 8. So that would be -1. Okay. So now we want to work out our differences. A is our first term. So this is A over here, the first term in our pattern. So we know that A is equal to 3. All right. Now we need to work out our difference. All right. So difference is term 2 minus term 1. Okay, or term 3 minus term 2. It doesn't matter. It's all going to be the same. So what's our difference in this case? You can pop it in the chat. Indeed, Timothy. Good, Michelle. Yes, Benedict. Yes, Christian. Okay, the difference is -2. Okay, so now when we come along and we answer this question, I'm just going to rub this out because you know where this comes from. So really, when we're coming along and we're answering this question, we've established, number 1, it's arithmetic. Therefore, we must use this pattern. How many terms are there? What is the first term? What is the common difference? Okay, so now substituting in, sum to 99 is 99 over 2. 2 times A we said was 3, plus n minus 1, 99, minus 1. And then I chose this one on particular because you must put your difference in brackets, okay, to remind you that you have to multiply. so many matrics forget to put this -2 in brackets, and then they end up subtracting 2 instead of timesing by -2. So even if it's positive, still put it in brackets. Okay, so we've got to multiply n minus 1 with d. Okay, not take it away. And then, of course, matrix, you're going to grab your calculator. I've got mine as well, and we're going to work out what the answer to this is. Okay. And if anybody gets there before me, you are welcome to put the answer up. Okay, I've got an answer. What are you? Yes, me too. Oh, wow, you guys are much faster than I am. Good job. Yes, I also get -9405. Okay, good job. So that's a simple, easy sigma notation for us. What they could also ask us is they could ask us to work backwards. Okay, so here we don't know what the number at the top is. We know that we start by subbing in 1. Okay, what does this equals 456 mean? Is this number that they've given us here, this 456, it's the total of all the terms, it's the sum, absolutely. This is Sn, isn't it? It's the sum of all the terms, correct. 6r minus 1, is it arithmetic or geometric? Arithmetic, absolutely. So once again, okay, this is my formula. Let's just clear the blue out the way. How do you notice which is which? Do you mean which pattern is which pattern? Do you mean the difference between whether something is arithmetic or whether something is geometric? Ah, okay. Hang on a second. Look here. Compare this question that we've just done to this one over here. Sorry, I'll pop these in the middle of the screen. There you go, Christian. How do you tell the difference? Okay, so what's the same is the sigma symbol. There's a number at the top and there's a number at the bottom. How we work out n is the same. Number at the top minus number at the bottom plus 1. But, Christian, the big difference is here in terms of the rule. That is an arithmetic rule because we are taking m and we are multiplying it by something and then adding and subtracting another number. So in this case, we're taking m, we're multiplying it by -2, and then we're adding 7. Okay, that is an arithmetic or linear rule. Here, look at this one. Okay, so we've got a value times by a base to an exponent. Okay, so because this one has an exponent in it, this is what makes it geometric. Do you see the difference? Okay, so they were so simple, exactly. Now, they're not going to tell you that. They're not going to tell you that this one's arithmetic and that one's geometric, but they want you to be able to look at it and tell from the pattern. Okay, so look at the rule. If the rule's got an exponent in it, it's geometric. If it doesn't have an exponent in it and it's an arithmetic rule, then it's going to be the other one. Okay, so now, working backwards very quickly. Let's just, I suppose we don't even need to rub that out. Where were we? Oh, yeah, over here. Okay, so we've agreed. It's arithmetic. So what have they given us? They've given us Sn. They've told us Sn is 4, 5, 6. We don't know what n is. That's what they're asking us to calculate. They want us to determine what n is, that last number that got subbed in. In order to be able to answer this question, we need A, we need D. Okay, so we get A and D by substituting. All right, so A will be obtained by subbing in 1. So this gives us 6 times 1 minus 1 plus 6 times 2 minus 1 plus 6 times 3 minus 1. There's the first 3 terms. We don't need to go any further than that. So that gives us 6 minus 1 is 5. 12 minus 1, that gives us 11. And then over 18, that would be 17. Okay, so can we all see that the first term, A, term 1 is 5. The difference is going to be term 2 minus term 1, or term 3 minus term 2. Can you see in this case the difference is 6? What I'm going to do is I'm going to rub this out just for space to write. You would have obviously left that there if you were doing your exam. Okay, and now you come along and you say to yourself, this is the formula that I'm subbing into. Okay, so Sn is 456 in this case, is equal to n over 2. 2a, a is 5 plus n minus 1, d is 6. Put your d in brackets. Okay, what I like to do here is I like to simplify what's inside the square brackets first. Okay, if you want to multiply 456 by 2 first and then expand the brackets, it's absolutely fine. Okay, but what I'm going to do, I suppose we can do the same thing. All right, so if we cross multiply, well, actually, no, well, let's not cross multiply. Let's just simplify what's inside the brackets and then we'll deal with the 2 separately. Okay, so that's going to give us 10 plus 6 times n is 6n. 6 times minus 1 is minus 6. All right, so 456 is going to be equal to n over 2. And then inside our brackets here, we've got 6n minus 6 plus 10 is going to leave us with plus 4. Okay, now the easiest thing for you to do at this point, I believe, let me just move this out the way, all right, is to multiply both sides by 2 to get rid of the denominator. Okay, so we want to get rid of this 2 over here. So if I times the right-hand side by 2, I'll get rid of the 2 on the right, but I've got to multiply the left-hand side by 2 as well. So 456 times by 2 leaves me with, indeed it does, thank you Pearl, 912 equals, now I'm going to expand my brackets. N times 6n is 6n squared. N times 4 plus 4n. All right, this ends up being quadratic. Okay, so which means I've got to get all my terms over to one side. And into standard form. Okay, what I would suggest at this stage, I mean, you could check and see if 912 is divisible by 6. If 912 is divisible by 6, which it is, it means that we can, mind you, we wouldn't be able to divide the 4. So you know what I think I would do at this stage? Quadratic formula. Okay, so Benedict, you would have got 2 answers. All right, so CP says x is equal to 12 or negative 38 over 3, then discard the negative 38 over 3. Yes, CP, why are you discarding the negative 38 over 3?
Because a term can't be negative.
Because?
A term can't be negative.
Okay, so a term number can't be negative and it also can't be a fraction. Okay, so that's why you're accepting the 12 as the answer. Okay, now what I just want to make sure of, Matrix, okay, is just in terms of setting out. I'm glad you understand how to work that out, and that's great. But let's say you got to this point now, right? They would penalize you if you didn't show where that had come from. So if you're going to use the quadratic formula, you must show that you have subbed into it. Okay, so you have to show this. You have to write n equals negative b plus or minus b squared minus 4ac all over 2a. Exactly. Therefore, n equals 12 or n equals 38, sorry, negative 38 over 3, which we all agreed we would disregard. Okay, and that's how we would get back to what n is. Everybody happy with that? All right, let's do something similar. Cool beans. Let's do something similar with a geometric one. And then if there's time, I found this monstrous sum. I don't know if we're going to be able to do that, but I'm kind of hoping that we'll be able to manage to do this one before we say goodbye. Okay, so let's do this one here. You can always try that next time if you guys are up to it. Okay, so now they want us to determine the value of m. Again, 24 and 1 over 5. Is it an SN or a TN? They're telling you that the sum of the rule is equal to 24 and 1 over 5, so it's an SN indeed. But now again, can you see when you look at this? Good. Yes, Karabo. Yes, Luyanda. Okay, good job. Can you see it's got an exponent in it? So this means we've got to use
Geometric.
Geometric, indeed. Where's it gone? There's it. Let's go and grab it. How come? Make life difficult for us here. Okay, so we've got to use this one. Okay, so let's go through this. We've got SN. We need A, so we need to sub in, and we need R. All right, so let's do that. Okay, so the first thing that we're going to do is sub in. So we've got 1 over 15 times 3 to the power of 2 minus 1. That is our first term. 1 over 15 times 3 to the power of 3 minus 1. That's our second term. Plus 1 over 15 times 3 to the power of 4 minus 1. And so it goes on. All right, but we just need the first 3 terms. Okay, so on our calculators, we would end up with our first value. Do you guys get 3 out of 15? Which would actually be 1 out of 5, wouldn't it? You getting the same answer as me?
Yes, ma'am.
Okay, all right. So I tell you what, let me just simplify that properly so that we are not wasting time. So we get 1 out of 5, right? Then as far as the next one is concerned, we're going to end up with do you get 3 over 5?
Yes, ma'am.
Yes, agreed. Okay, lovely. Okay, and then as far as the next one is concerned, we would have ended up with nine over 5. Did you get 9 over 5 as well? Yes, okay, oh, good stuff. All right, 9 over 5. Okay, so now we know SN is this freaky 24 and 1 over 5. Okay, we know that A is 1 over 5. We know this is a geometric pattern. So in order to work out the value of R, we have to say term 3 divided by term 2, or if we wanted, we could say term 2 divided by term 1. So if we say 9/5 divided by 3/5, what do we get? R is equal to, indeed, R is equal to 3 in this case. Good, well done. Okay, so now we know SN, we know A, we know R. We're going to be able to work out what M is. Now, be careful, be careful, be careful, be careful. Right? They want us to work out M. How would we work out the number of the terms in the pattern? The number of terms in the pattern is going to be the number at the top minus the number at the bottom plus 1. Okay, so we need to work out M minus 2 plus 1, which is M minus 1. That's the number of terms in the pattern. Is everybody okay with that? Because we did not start subbing in at 1. We started subbing in at 2. Okay, everybody. All right. So now let's do our sum. SN. Let's do it in purple. Okay. SN is 24 and 1 over 5. Let's make that improper. Okay. So we're going to say 24 times 5 is 120 plus 1. So that will be 121 over 5. That's SN. Is equal to A. A is 1 over 5. Okay. R is 3 to the N minus 1. All over R is 3 minus 1. Is everybody happy where we're at right now? Okay, so we've subbed into, yes.
I'm sorry for that.
That's okay, Karabo.
I'm just trying to understand the N minus 1 and the 21 over 5. 121 over 5.
Okay, so what I've done, Karabo, is I have taken 24 and 1 over 5 and I've made it into an improper fraction.
Oh, okay.
Okay. Yeah, so it's just, maybe it's one of those things that it's so easy that it's difficult. So do you remember when you multiply the denominator with the number in front and you add the numerator?
Yes.
Yeah.
Yes, ma'am.
Okay,
Oh,
no problem.
okay.
Okay.
Thank
Now,
you.
pleasure. The reason I'm doing that, okay, is because I want to try and make life as easy for myself as I possibly can. All right. I'm going to have to cross multiply here. I want to isolate the bracket because I want to solve for N. So my first step, matrix, is going to be cross multiplying. So I've got to multiply 2 with 121 and 5 with 1 over 5. Okay, so when I cross multiply 2 with 121, what am I going to end up with? 121 times 2 is going to leave me with 242. Let's go back to purple. Okay, when I multiply 5 with 1/5, I'm going to end up with 1. So on this side, I'm going to end up with 1 times 3 to the N minus 1. Does that make sense to everybody? You sure? Okay, so I've cross multiplied the 2 at the bottom with the 121 and the 5 at the bottom with the 1/5. Okay, 5 times 1/5 is 1. So 1 times 3 to the N minus 1 is 3 to the N minus 1. Beautiful. So now what I've got, I'm going to take the 1 over to the other side. Thus, 3 to the N is going to be equal to 2, 4, 3. Okay, and now my job is to write 243 as 3 to the power of something. So 243 written as 3 to the power of something is 3 to the power of 5.
5.
Yes, good, 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 good. Yes, it is. You must show that step matrix. Okay, you've got to write that. Let me just move this down. Come on, man. Come on, man. We're busy here. All right, so 3 to the N equals 3 to the 5. Got to show that step where I equate the bases. All right. Yes, Bahle, but we're not finished. Okay, so N equals 5. Indeed, yes, it does. But. Go back to the question. All right. N is 5. We've got to go back to this, Vatle. Okay, remember the number of terms in the pattern is the number at the top, m, minus the number at the bottom, 2 plus 1. Okay, so in other words, if I put, we're going to add 1. We're going to add 1. Yes, Pearl, quite right. So I'm going to take that 5 over here, and I'm going to substitute it in here in place of the n, yes? So in other words, n equals m minus 1. So if 5 is equal to m minus 1, then it means that m is equal to 6. Good. Yes, Michaela. Yes, Christian. Yes, Pearl. Okay, so go back and make sure that you read the question carefully. How are we feeling, Matrix? Does it feel good? Yes.
Yes, ma'am. So do you always do the n equals m plus minus 2 plus 1?
It depends what's there, Karabo. It depends on what they've given you, because the number of terms in the pattern is always the number at the top minus the number at the bottom plus 1. So let's say they gave us a pattern and it looked like this. And I'm literally just making a pattern up, right? So there's our sigma notation. And let's say here we also had m. And then here we had p equals 4. And then our pattern was 3 times 2 to the p minus 1. Okay, so now when I want to work out m, okay, the number of terms in the pattern, n, is the number at the top minus the number at the bottom plus 1. So now if you were trying to work out n in this pattern, you'd have to work it out by saying n is m minus 3. Whoopsie. Does that make sense?
Yes, ma'am.
Okay, so it's always the number at the top minus the number at the bottom plus 1. So you've just got to see what it is that they give you. Okay, if you start subbing in at 1, then it's easy, because the number at the top minus 1 plus 1 will be the number at the top. You know what I mean? But if they don't start subbing in, at 1, then you've got to have this extra thing that you've got to consider. Okay, all right. Now, what I was hoping, yes, Mihle.
Ma'am, I have a question about the question.
Of course, yes.
The 24 and 1 over 5, is that the sum of
That's
the whole pattern?
Yes, Mihle, that's this, yes.
And then is m the position of that specific number?
So
Since
m,
it's the last term.
No, m is the last number that we would have subbed in. So in other words, what we've done is we've worked backwards and we've figured out that m would have to be equal to 6 in order for us to have a sum of this pattern that gives us 24 and 1 over 5.
So if we substituted the 6 in the formula, we would get 24 and 1 over 5.
Yes, but we would have to generate all the terms. So in other words, what would happen would be this. Let me write it out for you, because it's so important that you understand what this means. Okay. So in other words, what we've done, sorry, I just want to rub this out as well. What we've done is this. We've worked out that if we take 1 over 15, 3 times, the first number we subbed in was 1. So 2 minus 1 plus 1 over 15 times 3 to the 3 minus 1 plus 1 over 15 times 3 to the 4 minus 1 plus 1 over 15 times 3 to the 5 minus 1. Hold on 1 second. Plus 1 over 15 times 3 to the 6 minus 1. 1, 2, 3, 4, 5 terms in this pattern. Okay, the number at the top minus the number at the bottom plus 1. What we've done is we've worked out that if we were to add all of those together, we would end up with 24 and 1 over 5. This is what they were asking us to calculate. Okay, so in other words, does that make sense, Claire?
Yes, ma'am.
Okay, so we worked out what would be the last number we would need to sub in if we wanted to get a sum for this particular series of 24 and 1 over 5. Okay, does that make sense?
Yes, it does. Thank you, ma'am.
Okay, it's a pleasure. It's an absolute pleasure. Okay, so now what I wanted us to try and do was that monster sum down here at the bottom. Now, did anybody write the NSC trials exams? If you did write the NSC trials exams, then what you would have done, the department trials exams, you would have seen this question, 7 marks, okay? And ordinarily, this looks like a really scary question, and it contains something that we haven't spoken about tonight, which is the sum to infinity. But don't you agree that this is the kind of question we would all look at and say, no ways, like we're not even trying to answer something like that, and we would leave it and we would move on. And actually it's really not a difficult question. All right, the first, we'll just see how far we get. I can always start with this on Thursday evening. I know we're kind of running out of time here, but can you see that the first term, is that arithmetic or geometric? Exactly, it's arithmetic. Good job. Second term, arithmetic or geometric? Exactly, it's geometric. On the right-hand side of the equation, okay, we haven't spoken about that tonight. What's that?
Sum to infinity.
Sum to infinity. Okay, sum to infinity, which is geometric. It can only happen with geometric patterns. And unfortunately, I haven't spoken about the sum to infinity pattern tonight, but we can certainly, it's just a case of literally subbing into a formula. Okay, so now what they want us to do is they want us to add a value, an arithmetically obtained value, to a geometrically obtained value, and equate it to the sum of a value that's obtained using sum to infinity. So really all we are doing, guys, is we are adding together, all right, a series of numbers plus another series of numbers and letting it equal another series of numbers. And there's one letter in this that we don't know the value of, and that is y over here, right? Even if you can't get all 7 marks, if you understand if you understand sigma notation, you can at least do a little bit of it, okay? So now, right, arithmetic, we know which formula to use. If we want to work out the value of the yellow term, all right, if I write in yellow, can you guys see okay?
No, ma'am.
You can't see okay. All right, so we won't write in yellow. All right, so what I'm going to do is I'm going to write, is this better? Is that green better?
Can you use another color, ma'am?
No problem. Okay, I think the sort of darker colors are better in this case. All right, I'm going to write with purple. Is purple okay?
Yes, ma'am.
All right, good stuff. Okay, so now the last number we sub in is 5. The first number we sub in is 1. Okay, so we're going to replace the P with 1. So in other words, if we now want to generate the first 3 terms of this pattern, we're going to end up with 4y plus 3 times 1 plus 4y plus 3 times 2. Okay, and then we're going to continue to add those together until we get to 4y plus 3 times 5 will be the last one that we add in. All right, so how many terms are there in this pattern? Number at the top minus the number at the bottom plus 1. So there are 5 terms in this pattern. Exactly. So we're going to have 4y plus 3 plus 4y plus 6 plus 4y plus 9 plus 4y plus 12 plus 4y plus 15. Does that make sense to everybody? One, 2, 3, 4, 5. Okay, so in other words, the sum of this is going to be 4y plus 4y plus 4y plus 4y plus 4y, which gives us 20y. And then 3 plus 6 plus 9 plus 12 plus 15 leaves us with how much? 3 plus 6 plus 9 plus 12 plus 15 leaves us with 45. So in other words, this bit over here, this sum here, the sum of 4y plus 3p, when we begin by subbing in 1, the last value we sub in is 5, is 20y plus 45. Now let's do this one over here, the pink one, okay? All right, it's a geometric pattern. Again, let's start subbing in. So we've got 3 times 2 to the 4 minus 1 plus 3 times 2 to the 5 minus 1 plus 3 times 2 to the 6 minus 1. Let's just move this out the way. And then 7 is the last number that we're going to sub in. 3 times 2 to the 7 minus 1. We can work out what that is on our calculators as well. All right. So that's going to leave us with, so that would be 24. This would be 48. This would be 96. Just double check me, it should be. Is 192. Yeah, okay. And now when we add all these numbers together, 24, 48, 96, 192, we end up with 360. Okay, so this bit over here is 20y plus 45 plus 360 equals the one in blue on the right-hand side. So now sum to infinity. Okay, the sum to infinity formula I haven't actually put on the page, but sum to infinity looks like this. Okay, so sum to infinity is a over 1 minus r. Okay, so we need a and we need r. Again, we're going to start by subbing in. Okay, so when we sub in, we've got 1 over 3 to the power of 1 minus 1. Plus 1 over 3 to the power of 2 minus 1 plus 1 over 3. No, it really is. It's so easy. You're just adding two numbers together and making it equal to something. Okay, to the power of 3 minus 1. Okay, so the first term in this series is 1. Agreed? The second term is 1 over 3. And the third term is 1 over 9. Okay, so 1 over 3 to the power of 0 will be 1. 1 over 3 to the power of 1 is 1 over 3. And 1 over 3 to the power of 2 is 1 over 9. Agreed? Okay, so what is A? A is equal to 1. So A is equal to 1. 1 minus R, what is R equal to? So it's 1/9 divided by a third, or 1/3 divided by 1. It's going to be 1/3, right? So 1 minus 1/3. Everybody following me? Okay, so the sum to infinity in this case is 1/1 minus a third. So we're going to finish this before you guys go. And I'm getting a sum to infinity of 3/2. Okay, so now let's just put this all together, okay? Remember the first bit that I first did in yellow, all right? That was 20y plus 45. That was the first term. The second term was 360. And this needs to be equal to our sum to infinity, which is 3/2. That's all this question means. There's just a lot of working out, but it's really not that difficult, but it's intimidating because of all these sigma symbols. Okay, but if we understand what sigma notation means, and we understand how to generate the series, where to start, where to end, it really is not so intimidating. Okay, so now we've just got, exactly, it's not. So now we've got a really easy linear equation that we need to solve. And you're going to see y ends up with a really, really weird answer, and you'd think you were wrong, but you're actually not. Okay, so now let's just finish this off. We're nearly there. Okay, so 20y plus 360 plus 45.
405.
How much?
405.
Thank you, my darling. 405 equals 3/2. So now we need to multiply through by 2, don't we? So that's going to give us 40y. Then times that by 2 is going to give us 810, and that's going to be equal to 3. Yes? Okay, thank you, Christian. All right, so last thing, 40y is going to be equal to 3 minus 810, leaves us with negative 447. And now we've got to divide that by 40. No, hang on, something's wrong here. What have we done wrong?
It's 807, ma'am, not
Oh, sorry.
negative 800.
Beg your pardon, quite right. And minus 807 divided by 40. There we go. We end up with y as negative 20, 175. Okay, exactly. And that, matrix, is indeed the right answer. Okay, so there's your crash course in sigma notation. I hope that you found this helpful and useful, and that it makes a bit more sense to you. I'm glad we were able to do a difficult question at the end. And then please, 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 if you've got any questions that you come across that you want me to work through with you, yeah, hey, there we go, 7 marks, Karabo. Well done, matrix. It's a greatest pleasure, Christian. It really is. So please email me, and then I can, it's a pleasure. Then I can do them with you. Okay, so I'm sorry, I've gone 1 minute over, so I better hand you back to Nikayla. It's the greatest pleasure, Sayuri. It's the greatest pleasure, Kwandisa. I hope
ma'am?
Yes.
Can I ask a question quickly?
Of course you can. Of course you can.
So we can round that up to minus 20,18 because 2 decimals, because I know once I left it, like for instance, it's this number, I left it as 20 comma minus 20 comma 17 and
Mhm.
then mark it right, but when maybe I say minus 20 comma 18, they're gonna mark it wrong.
You know what? I think that if you either answer, I think that they would mark it right at matric level. I really don't think that they would mark it wrong. Generally speaking, we would round to 2 decimal places. So if we did write it as negative 20,18, they by that stage, they're not going to split hairs over how many decimal places you've rounded it to. I think as long as you didn't go minus 20,17, because then technically speaking, you haven't rounded correctly. But there would probably only be one question in the entire paper where they would penalize on rounding. So if that wasn't the question, then you wouldn't be penalized for that. But if it was, then you would be. Okay. Does that
Okay, thank you, ma'am.
answer your question? Pleasure.
Yes, ma'am.
Pleasure.